Okay, what was the question? I must have written it over here.
Yeah, the question is the houses of a row are numbered consecutively from 1
Okay,
to 49.
let me write it.
Okay.
Yeah, I'm explaining it. You are having the question, right?
Yeah, I have.
So basically, the houses of a row are numbered consecutively from 1 to 49. That means house number 1, house number 2, house number 3, house number 4, house number 5, like that. The pattern is going on till house number 49. Okay.
Okay.
Show that there is a value of x such that somewhere we are having house number x. Okay, such that the sum of numbers of houses preceding the house number x. Wait. Sum of numbers of houses preceding the house number x. Okay, sum of number of houses preceding the house number x. I thought that is saying that the houses preceding this one is the houses following this one, but no, it says that the sum of number of houses, sum of this all preceding the x, okay, is equals to the sum of all the houses following x, right?
Yes.
Okay, that means 5 plus 6 plus 7 plus dot 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 before x must be x minus 1, right? Because consecutive numbers are there, right, Zoha?
Yes.
And after x, it must be x minus x plus 1, then x plus 2, right? Like that, right?
Yeah.
Okay. So that means sum of all the numbers till x minus 1 must be equals to. Okay, I'm writing the statement over here so that it will make sense to you that sum of houses preceding x, sum of number of houses preceding x, that means sum till x minus 1, yes, is equals to sum of numbers of houses, numbers, sum of numbers we are finding. Okay, sum of numbers of what? The houses. Each nameplate is having the numbers. Sum of numbers succeeding or following x. Okay, that means sum till x minus 1 is equals to sum after x. That means from x plus 1 to 49. Getting it?
Yeah.
So when we started the discussion of this concept, Zoha, somewhere I told you that these are the formula which we know, that nth term formula, sum of n terms formula. These formula only applicable for sum of n first n terms, right?
Yeah.
Or number of the nth term from the first, not from the last, not from the middle, from the first. So if we have to find sum till x minus 1, maybe we'll be able to generate a expression, okay, from first till x minus 1. But on the other side, the sum from, like, it is like this: 1, then 2, then 3, then 4, then 5, then 6, then 7, and somewhere x. Then it's just before it x minus 1, just before it x minus 2, like that. And after it x plus 1, then x plus 2, like that. It will keep on going until 49. And the condition says that sum till x minus 1, that means sum before x is equals to sum of numbers after x. That means from x plus 1 to 49, right?
Yeah.
So for the first one, from 1 to x minus 1, we can write as x minus 1 and we can use the formula, right?
Because we got the
Sum of first x minus 1 terms we are finding, right?
yeah.
But the next one, that part which I have written on the right, how to take the formula, how to use the formula for that x plus 1 to 49, that is the confusion, right?
Yeah.
Okay. So we are not able to use the formula for that portion. So we will be doing one arrangement, Zoha. What we will say that let's take the sum of all 49 terms. Okay. From the first till 49. And from here, if we will, from sum of 49 terms. From here, if we will subtract the sum till x, then we can say the remaining will be the sum of x plus 1 to 49. Yes or no?
Yeah. Because-
Getting it?
Yeah, I'm getting it because then we'll find the
Okay. So what we'll do, we will take that sum of number of houses preceding x, that means sum till x minus 1, is equals to sum of number of houses following x. That is really difficult to write, but we came to the conclusion that let's write that sum of all minus sum till x, whatever will be remaining, this will give the sum of numbers of houses following x. Is it making sense to you, Zoha?
yeah, it's making sense now.
Okay. Now we will put the formula, we will try solving it. Let's check it what can be done. So we don't know anything. We just know that 1 to 49, these are how the house numbers are distributed. So total n is 49, right, Zoha?
Yeah.
Okay, and 1 2 3 4, these, this is how the house numbers we are having. Okay, so one more thing we know, that a is the first term is 1, house number 1. Okay, the common difference is again 1, right, Zoha?
Yeah, it is one.
Okay, so let's find it. This n means total number of term is 49, total number of term. However, while finding the sum of x minus 1 term, we will not be using this n. Please don't just write it as a total number of term. Okay, this much data we are having. So x minus 1, that means n by 2. 2a, that means only 2. Okay, plus n minus 1 into d, that means x minus 1 minus 1 into d, right, Soha?
Yeah.
Okay, sum of 49 terms, that again n by 2, let's write it, n by 2. 2a, that means only 2, plus n minus 1, that means 49 minus 1, 48, into d, that means 1. Is it clear so far?
Yeah, now it's clear.
Minus sx, that means x by 2, again 2a, that means 2, plus n minus 1, that means x minus 1, into d, that means d is what? D is 1. Okay, this is what we are
D is
getting.
one.
Let's, yes, because house number 1, house number 2, house number 3, house number 4, house number 5, like that we are. And the question says that, basically, let me give you one example. Suppose we are having random terms, like 2 is there, then 4 is there. Okay, then suppose 8 is there. Okay, then 16 is there, or maybe I'm just giving a random example. Okay, I'm not trying to create an AP. I'm just giving a random example. So suppose 8 is there, then 6 is there. Okay, a random, just a sequence I have written. A random sequence. I'm not saying it's in AP. Okay, I am saying, and then 0 is there. Okay, I am saying some of the numbers preceding 8. Okay, preceding 8, whatever numbers are there, that sum is equals to the sum of numbers succeeding 8. So can we see 2 plus 4, that is 6. Preceding 8, these two terms are there and sum is 6. Succeeding
Yeah.
8, the terms are 6 and 0, and again the sum is 6. Is it making sense, Zoha?
Yeah, it's making sense. It's like the
Okay,
sum
so
both of them
this
are equal.
exactly
We have to just
preceding. Exactly. We just have to get this x over here. That what exactly is that x? Okay, let's
okay.
check it. Like x can be any number. Okay, maybe towards the last. That sum before x, all the numbers sum before x is equals to sum of the numbers after x. Let's check what is x. So x minus 1. To calculate this one, yes, we have to do lot of simplification maybe, but no worries, we'll be doing it. So 2 plus x minus 2, right? So,
Yeah, it is minus
okay, 49 by 2 I am writing as it is for now. And 48 plus, this 48 into 1 is just 48. 48 plus 2, 49, 50 we are getting, right? So,
2. Yeah, when you do the addition
exactly.
multiplication.
The x by 2, here we are having 2. Here we are having x minus 1. Okay, let's open the bracket. So basically, I can see we'll be having 2 minus 1, that is 1 only. Okay. So this 2 gone. We are just left with x multiplied with x minus 1 by 2. And here we are having 49 by 2 into 50. Why not I am cancelling this 2 with 50? Because I want to take out 2 common here and to cancel out both side denominator. Okay.
Okay.
Here bracket will be having x and 2 minus 1 is plus 1. Let's continue. Now, what I told you, let's take out 2 common. Here, 2 is already the denominator of only x minus 1 is a combined term, and that's the denominator we are having 2. So that is fine. Or other side will be taking 2 common from the
Yeah,
denominator,
yeah. So it will be
and we are
49
having
into 50 minus
hmm,
x into x plus 1.
hmm. And now this 2 I'll cancel it.
Yeah, you take 2 out.
So we are left with, now let's do the multiplication. We don't have any option. X square minus x is equals to 49 into 50 is what?
Is it like 2450?
Yeah. Then minus x square and then minus 1 or plus 1. Zoha,
It will be plus 1.
is it plus 1? Here minus sign
Oh,
is
that
there.
will not minus 1 for your. Yeah, it's minus 1 because
Okay.
it's
Now
directly.
x square here, x square there also we are having, but it is not getting cancelled. This x square will go to that side, it will be plus x square. Okay.
Okay.
Minus x is still there. 2450 minus 1 will be 2449, right? So
2449. Yeah.
that is equals to 0. So we are left with 2x square minus x minus 2449. Okay, just a second. Let me check like the simplification is correct or not. Wait, here we have done one mistake. This x we multiplied with this one. This x we will multiply with this one also, right? So,
Yeah, so it'll become minus x instead of just 1.
exactly.
Then we
Okay,
have to
that's
take
what.
this x along with minus x for on the other side.
Yeah. So this x if we'll be taking, it will come and sit with plus sign over here, right?
Yeah,
And x gone, right? And this will still be 2450, right?
that'd be 2, 2, 4, 5, 6.
Okay. So do we want to say that 2x square is equals to 2450 or 2x square minus 2450 is equals to 0? Yes, we do. We want to say 2x square minus 2450 is 0. That means 2x square is equals to 2450. That means x square is equals to 2450 by 2 to 1 times 2 to 2 times 4 to 2 times 4 to 5 times 10. X square is 1225, which is a perfect square number, and it is 35 square. Okay. X is plus minus 35, but since we are talking about the placement, it is 35. That means before 35, the sum of all the numbers. Okay. Do you know this formula, Zoha? Okay, you know it. You know this formula. Okay, we got x is a 35. Okay, मतलब 35 के पहले जितने भी नंबर्स है सारे का सम किसके इक्वल होगा 35 के बाद जितने भी नंबर्स होंगे सारे का सम. चलो चेक करके देखते हैं क्या ये सच में सच है. तो चेक कैसे करेंगे. कैलकुलेटर आई एम शोइंग यू विद द हेल्प ऑफ द कैलकुलेटर. जस्ट अ सेकेंड.
Okay.
Do you know, Zoha, from 1 to 35, 35 we got, n is of 35. So from 1 to 34, we want to check the sum, right?
Yeah.
Okay. 35 के जस्ट पहले तक जितने भी नंबर्स है सारे का सम किसके बराबर है. 35 के बाद जितने भी नंबर्स है सारे के सम के बराबर. ओके. तो मतलब कि 1 to 34 तक का सम, राइट. उसके लिए हमारे पास एक फॉर्मूला था जो हमें किसने दिया था. गॉस ने एक फॉर्मूला दिया था ना, n इंटू एन प्लस वन बाई टू. डू यू नो दैट. जोहा,
Yes.
सम ऑफ फर्स्ट एंड नेचुरल नंबर फाइंड करने का एक फॉर्मूला था n इंटू एन प्लस वन बाई टू.
Yeah, yeah, we know that one. Yeah. And 2 n plus
Okay,
1.
n into n plus 1 by 2. So I'm going to use the same formula. Can you see my screen.
Yeah, I can see your screen.
हमें क्या करना है 1 से लेके 34 तक का सम फाइंड करना है. मतलब n इंटू एन प्लस वन बाई टू. 34 इंटू 34 प्लस वन. Am I making sense?
Yeah, you're making sense.
34
34.
into 34 plus 1, that means 35. Okay, and that divided by 2. You can write this 2 in bracket and then you can write divided by 2. Doesn't matter since it is in multiplication. So can you see, Zoha, we are getting 595.
Yeah, we are.
Okay, let's check
So the sum of
from
the first 35 number is 590.
now let's check from 36 to 49. What is the sum? I am writing it. Now I don't know any formula. I'll be writing 36 plus 37 plus 38 plus 39 plus 40 plus 41. Wait, 41. 49 till 49 we are having. That's why I am writing it. Otherwise, I would have told you that is the answer. 43 plus, you just keep on checking, am I writing the numbers in a sequence or no?
Okay.
44 plus 45 plus 46 plus 40,
7,
47 plus
10, 48, 40,
48
and 49.
plus 49. Can you see Zoha?
Yes, I can see it.
ओके, तो इसका मतलब जैसे हमने क्वेश्चन में समझा था वो राइट था कि जो भी नंबर्स है एक्स के पहले सारे का अगर हम सम कर ले और एक्स के बाद जितने नंबर्स है सारे का अगर हम सम कर ले, ओके, हम हाउसेस को काउंट नहीं कर रहे, 1 2 3 4 5 हाउसेस है ऐसे काउंट नहीं कर रहे, हम नेम प्लेट पे देख रहे हैं, अगर हाउस नंबर 2 लिखा है तो हमने 2 ले लिया, फिर दूसरे नेम प्लेट पे देख रहे हैं अगर हाउस नंबर 3 लिखा है तो हमने जो 2 लिया था उसमें 3 हमने ऐड कर लिया. Getting it?
Yeah, I'm getting it.
Okay, so this is how we are adding, and hence we are getting the number of houses, the numbers, okay, of houses before x is same as the number of houses after x. Clear?
Yeah, clear.
So yeah, let's continue. So we are going to start triangle, right?
Yeah.
Now, do you understand what is like congruency concept is clear to you, Zoha?
Congruency, yeah, it's clear.
Okay. So here we are going to discuss similarity. Okay, and just a second. We will also be discussing the basic proportionality theorem over here. Just a second, let me check whether I can start with similarity or basic proportionality theorem.
Okay.
Let's get an idea about similarity, then I'm going to take basic proportionality theorem. Okay. So whenever similarity, similar figure. So when I'm drawing, or suppose a rectangle I'm drawing. Okay. Suppose I have drawn a rectangle ABCD, and a rectangle I have drawn PQRS. Now congruency means we understand that two shapes are exactly same in shape also, in size also. Size also has to be same. Okay. That's the meaning of congruency. Right, Soha?
Yeah, they're exactly the same. Like all of the
Ex-
properties are the same.
yes, everything is same. But similar figure means they are like the same figure we are having. Like I am comparing a rectangle with a rectangle, but the size is not same. Now the question is then how we will be checking whether it is similar or not? Any measurement, anything will work? No, anything will not work. Basically, similarity means suppose this side AB is 10 centimeter, okay, and the length of the rectangle is 10 centimeter and the breadth of the rectangle is 8 centimeter. Okay. So, just a second. Just a second. Yeah, let me take this. Now, in PQRS, suppose the length is 2 centimeter. Okay. And here the breadth is, or maybe let me change the data. Okay, this is how we have maintained the length and breadth, okay, of this rectangles. Now it is perfectly fine. So this two figure, I am saying that these two are similar. What is the meaning of that? Only the shape is same, that only matters? No. Okay, it must be compressed. The figures must be compressed or stretched in a certain manner. What is that particular condition? The condition is AB over PQ. When you will be finding, what are you getting the ratio? Let's check it. AB is 10 centimeter and PQ is 2 centimeter. What are we getting the ratio? 5 is to 1, right?
That's
So
to one, yeah.
now similarly, if we will be finding BC is to QR, what we will be getting? Again, we are getting 5 is to 1, right? So these two figures are similar figure. The condition for similarity is the sides must be in same ratio, or sides are proportional with each other. Basically, this terminology proportional means maintaining the same ratio. Okay, so sides are in proportion, that means sides are maintaining the same ratio with each other. Okay, so we are checking whether the sides, all the sides, not only this two. Then why I'm not checking the other sides? Because it is again length only. Okay, this is again 2 centimeter only, so I don't need to check, do I?
You don't need to because it is the same.
Okay. Okay, again same we are having. If I will find the ratio between CD to SR, again I'll be getting 5 by 1. If I'll be finding the ratio between AD to PS, again I'll be getting same 5 is to, this is 1. 5 is to 1. Okay, so the ratios are equal. The ratio between the sides, all the sides must be equal with each other. Apart from that, each and every angle also has to be same. Okay, then only we will say that these two figures are similar figures. So similar figures, like what are the criteria? The criteria is the sides must be in proportion. If you are having a shape, then you must stretch it or compress it by maintaining a proper ratio between the sides, not randomly here and there we are stretching it. We are stretching it like with like very specific measurement. If we are just compressing the first of side by half, we have to compress the other side also by half, we have to compress the third side also by half. If that way we are compressing or stretching the figure, then only we can say the two figures are similar figure. Apart from that, we also have to be careful, each and every angle also has to be same. So here why we are not comparing the angle? Why I am not comparing the angle over here? Because I said initially that these two are rectangle, and rectangle means each and every angle will be 90 degrees. So I don't need to compare the angle A is equals to P, angle B is equals to Q. I don't need to compare because here rectangle means any one of the angle will be 90 degrees. Yes or no?
Yeah, it will be.
Okay, so angle also has to be same. Sides must be in proportion, corresponding angle must be equal with each other, and then only we will be saying that two figures are similar with each other. Okay,
Okay.
now here we understood that similar doesn't mean that it will like exactly be same measurement. No, only if the one of the figure is very huge, another figure is teeny tiny, still we can say it's similar, but we have to check whether the sides are extend, they just stretch or compress in a proper ratio or not. Okay, or
Okay.
each and every, and also each and every angles are same or not. So from now onward, how we used to write, like previously, when someone will say that triangle ABC is congruent with triangle PQR, how we used to write that, we know that by CPCT. Can you tell me by CPCT what can be taken out from here, Zoha?
like by CPCT.
Hmm. Corresponding part of the congruent triangle, what can we say? If I am saying triangle ABC is congruent with triangle PQR, then what can be taken out?
Like we can equate the angles because it's given that the angles are equal. Like we can write,
Angle A is equals to angle P, angle B is equals to angle Q, angle C is equals to angle R. And we can also say that side AB is equals to side PQ. Congruency I'm talking about.
yeah,
Side BC is equals to side QR, and side AC is equals to side PR. Okay, from the name only we write this. We don't even have to look at the triangle. The name is written so specifically, okay, so in such a well mannered way that we can say angle A over here is equals to angle P over there, angle B over here is equals to angle Q over there, angle C over here is equals to angle R over there. Similarly, AB side is equals to PQ side, BC side is equals to QR side, and AC side is equals to PR side. That this much we used to get from by CPCT, right?
yeah,
Corresponding part of the
of the
congruent
congruent
triangle.
triangle.
Now, there is a sign for similarity also. Here also specifically we will be talking about similarity of triangle only. Okay, so if I am saying that triangle ABC is similar, this sign we'll be using from now onward for representing is similar. Okay, triangle ABC is similar to triangle PQR. Then we can say that side AB is not equals to PQ. Okay, side AB by PQ must be equals to side BC by QR must be equals to side AC by PR. Apart from this, the angles will also be same. So again, angle A over there, angle P over here. Okay, angle A and angle P equal, angle B and angle Q equal, angle C and angle R are equal. This is the meaning of similarity. That was the meaning of congruency. Is it making sense to you, Zoha?
Yeah, it's making sense.
Okay, so similarity doesn't mean exactly same. Figures are same, circle with circle, triangle with triangle only we can compare, but the size is not same. Okay, but it is a stretch or compress in a specific well mannered way. That's called similarity by maintaining a proper ratio. But here also we are saying that the angles are same, so both the triangle must be same. It must be same. Is it so? If I am
Yeah,
telling you there is a triangle ABC where angle A, angle P are like there is a triangle ABC, there is a triangle PQR. Where I am saying that angle A and angle P are same, angle B and angle Q are same, angle C and angle R are same. So can you say that both triangles are exactly same in size also? Can you say that?
yeah, we can because it's congruent.
No. If I am saying that suppose Zohar you are having a triangle that is MNO and you are having a triangle that is SRT. Okay, here angle M is equals to their angle R. Here angle N is equals to their angle S. And here angle O is equals to their angle T. Now, can you say that these two triangles are exactly same in size also? Can you say that with this much of information, only this much of information, the angles? Can you say that these two are same in size? Same in size means what? This palm and my this palm is same in size. If I'll put it like this, no, both are covering each other completely, right?
Yeah.
Okay, that's called same in size, ditto, exactly same. But this two triangle, is it ditto? If the angles are equal, I have told you angles are equal. Is it, will it be ditto exactly same?
No, because just because the angles are the same, it doesn't mean that the size will be the same. Who knows, maybe this one triangle is bigger than the other one, but they still have the same angle.
Exactly. Okay, so only angle doesn't justify that the sizes are same, because in real life also you can check it. If you can draw a bigger line, maybe of 5 centimeter, maybe of 10 centimeter, and you will be able to draw 60-degree over there. Okay, and then with the help of the protractor you will be able to draw 50-degree over here. Okay, and when you will join them, you will automatically be getting 70-degree over here. And same thing you can do with a smaller teeny tiny line which is 1 centimeter. Still you will be able to draw 60-degree over here. You will be able to construct 50-degree over here. And of course you will be getting 70-degree over here, but these two triangle are not same. So angle just doesn't justify. These two are exactly same. Ditto, that means congruent. Okay, these two are not congruent. That's why you can recall angle, 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 congruency criteria doesn't exist, right?
Yeah, it doesn't exist.
Okay. Now we are talking about the similar shapes. So I was explaining you what exactly is the meaning of similarity. Similarity means sides are in proportion and angles are equal. Okay. Now for similarity also we are having criteria. Yes. Okay, for similarity also we are having criterias. Okay, and few more thing you need to know. When we are talking about the circle, if I am comparing this circle with this circle, and I told you, Zoha, that similarity means sides are in proportion and angles are same. So if both are circle, angle will be same, right?
Yeah.
Okay, 360 at the center, the complete, here also 360, the complete angle. Angle, we don't even have to think. Angles, it's a circle, it will maintain
360. Yeah.
360. Okay. Now the size. Okay. So if I am saying the radius, in circle we talk about the radius, right? So
Yeah, we talk about the radius.
if I am saying the radius of this circle is 5 and the radius of this circle is 2 centimeter. Now if we will check whether the ratios are same or not. So are you getting the idea that with what we will compare the ratio? When we were having the rectangle, we were comparing the ratio of AB by PQ. We were comparing that ratio by the another side's ratio, right?
Yeah.
Okay, when we were having the triangle, then we were comparing the ratio AB by PQ is equals to BC by QR. Is it so? If these two ratios are same or not, that's what we were comparing. But here, when we are talking about the circle, with what we will be comparing the radiuses? If I have to find the ratio between radius 1 to radius 2, okay, if this is R1, this is R2, I'll only be getting one fraction, one ratio, 5 by 2. Okay, with what we will be comparing this one? Here we don't have any other side, right?
Yeah, we don't.
Okay, that's why we say that circles, any two circles are always similar. Any two circle, any measurement you draw, it's always similar with each other.
Okay.
Getting the idea?
Yeah, I'm getting.
Similarly, there are few more steps which will always be congruent. Sorry, I mean similar, where we will not be able to compare the ratios and all. And one of the figure is square. Okay, if you are having a square and you are having another square, whatever be the side over here, 8, here maybe 3. Okay, this is also 8, this is also 8, this is also 8, because we are talking about a square. Okay, so all side must be same. Okay, that is also a square, so all side must be same. So of course the ratio, automatically the ratio will be same. Yes or no? 8 is to 3, 8 is to 3, 8 is to 3, 8 is to 3. Right, Zoha?
Yeah.
Okay, so again any two squares are always similar. कोई भी दो स्क्वायर हो, okay, anything can be the side, it must be always similar. Okay, next. Now, the next figure which will always be similar will be equilateral triangle, because here also again the same thing. When you will compare the ratio, automatically the ratio will be same. Are you getting it?
Yeah, because it's equilateral triangle. Like,
It's an equilateral triangle. Okay. So all sides are same only. Of course, the ratios will be same. Okay. And in equilateral triangle, you can, if you are thinking about the angle, of course, each angle is 60 degrees. So angle is also same, right? Zoha.
yeah, it is.
Okay. So if this is 5 centimeter, if this is 2 centimeter, anything. Okay. Any two equilateral triangle are always similar. So these are just a few. Apart from that, for other figures, Zoha, we have to check whether the figure exactly is it similar or not. Okay.
Okay.
Now we will be discussing basic proportionality theorem. Okay, which is very important theorem given by Thales. Let me take that. Again, we will be discussing similarity. I mean the criteria of similarity. What are the criteria? How we'll be solving the questions? What we will be writing by congruent, I mean corresponding part of similar triangle. Okay, we'll be using this concept, we'll be solving the question. We'll be having the detailed discussion of this similar triangle, but in the second exercise. In the first exercise, basically you need to understand what is basic proportionality theorem given by mathematician Thales, which is also known as Thales theorem. Okay, just a moment before writing it, let me check anything I am missing. Yes, this theorem is very important. So let me write the theorem. First, you need to understand this theorem. So, okay, let's do one or two questions related to this theorem, and then I'll be showing you how to prove it. So the statement I'm writing it. If a line is drawn parallel to one side of a triangle to intersect the others two sides in distinct points, the other two sides are divided in the same ratio. Okay, let's see what the theorem says. Here the theorem says that given by the mathematician Thales. Okay, we also call it Thales theorem. So instead of basic proportionality theorem, if you will be seeing anywhere Thales theorem, you must understand we are talking about this theorem only. Okay, what the theorem says that if okay, so the theorem says that if we are having a triangle, if we are having a triangle, okay, in that triangle, suppose ABC is a triangle. In this triangle, suppose there is a line parallel to one of the side. Okay, if I am drawing a line parallel to any one of the side of the triangle. Suppose this is a line DE parallel to BC. Okay, if such a line I am drawing which is parallel to one of the side and intersecting the other two side at distinct point D and E, then this line, okay, will divide AB and AC in same ratio. That means AD by BD is equals to AE by EC. This ratios will be same. Okay,
Okay.
let me read the theorem as well. If a line is drawn parallel to one side of a triangle, okay, and intersect the other two sides, that means you are not drawing, you are just drawing a line which is touching the other two side. Of course, it is not just lying in the air. Okay, just touching the other two side, intersecting the other two side at distinct point, okay, D and E. Then the other two side are divided in the same ratio. The other two side AB and AC are divided in the same ratio. Your line can look like this also. It's not just like this, because you will be solving different questions. So you must be very clear that if you are having a triangle ABC, okay, and if there is a line parallel to one of the sides, so suppose you are having a line PQ parallel to PQ parallel to AB, then the ratios will be same. Which ratio? This ratio. This CQ by QA will be equals to CP by PB. Is it making sense, Zoha?
Yeah, it's making
The
sense.
side AC, whatever ratio it is getting divided, similarly side BC will also divide. Okay.
Okay.
So this is called the Thales theorem or the basic proportionality theorem. That if you are having a triangle, if there is a line parallel to one of the sides, suppose this side are parallel, then the ratios are same. Which ratios? The ratios, if you are taking first from here, this one, okay, then this one, then here also you take in that manner only, this one, then this one. Please don't mix up. Okay, if you are taking from that end point, here also you must take from this end point. Am I making sense?
Yeah.
Okay, so let me give you a few questions. Suppose we are having a triangle. Okay, here the ratios, like it's given over here, that DE is parallel to BC. It's given over here. If only we know, If only we know that the lines are parallel, then ratio we can compare by ourselves. That's what the Thales theorem says. That's what the basic proportionality theorem says. If there is a line parallel to one of the side, then the ratio will be same. Which ratio? This AD by DB is equals to AE by EC. Are you getting it, Zoha?
Yeah, I'm getting it.
Okay, please find the unknown side, that is AD.
Good morning, ma'am.
You have class with me, Zana?
Yeah, they scheduled a class with you for 8 o'clock.
Just, but,
Ma'am,
yes, yes, Zoha.
AD is 2.4.
Okay. Yes, Zoha, our class timing was, it was consisted of 1 hour, right?
Yes.
Okay. I think by mistake my team has given your name again. Okay. So yeah, let me check
The class
first.
finished.
So AD you are getting x over 7.2 is equals to 1.8 by 5.4. AD you are getting Zoha what? Yes.
Yes, I'm getting AD is 2.4.
Yeah, I think so. Just a I removing the decimal, you will be getting 18 into 72 by 54, but here one more zero will reflect. This is in numerator. We are multiplying numerator by 100, denominator by 100, so one zero will be.